Hello friends, today we take up electric dipole in uniform electric field. What happens to the dipole when placed in uniform electric field? So that we are to see today. First point, introduction. An electric dipole free to rotate about an axis passing through its midpoint perpendicular to its axis when placed in uniform electric field inclined at an angle theta with the field experiences a torque tau equal to P cross E. I repeat, an electric dipole free to rotate about an axis passing through its midpoint perpendicular to its axis when placed in uniform electric field inclined at an angle theta with the field experiences a torque tau equal to P cross E. Now we go to second point. We develop physical situation. Consider an electric dipole consisting of two charges plus minus Q. Consisting of two charges plus Q minus Q, that is plus minus Q, separated by a small distance 2a, such that its electric dipole moment P is equal to Q into 2a. Mark it as equation number 1. Let the dipole free to rotate about an axis passing through its midpoint perpendicular to its axis be placed in uniform electric field E inclined at an angle theta with the field as shown. Now forces acting on the dipole. In this situation, when we have placed the dipole in a uniform electric field, the dipole is free to rotate about an axis passing through its midpoint perpendicular to dipole axis. Okay. Now what happens to it? It experiences different forces. Now at the third stage we understand about the forces acting on the dipole. The force on plus Q. Say F plus is equal to QE and is along the field. And on minus Q, say F minus is equal to QE again and is anti-field as shown. Its direction is this side and its direction is this side towards the field. F plus equal to QE is towards the field and F minus equal to QE is opposite to the field. So these are the forces acting on the dipole. Now components of the forces, this is F plus and F minus. How F plus and F minus can be resolved into components, let us see. Now F plus can be resolved into two components, F plus cos theta along axis of dipole and F plus sin theta perpendicular to axis of dipole. Similarly, F minus can also be resolved into two components, F minus cos theta opposite to axis of dipole and F minus sin theta perpendicular to the axis of the dipole and opposite to F plus sin theta as shown in diagram. So you mark the components clearly and try to understand it. Now we come to net force acting on the dipole. In the fifth step, we talk of net force acting on the dipole. Now components F plus cos theta and F minus cos theta, being equal in magnitude and opposite in direction, and their line of action being same, cancel each other as if they are ineffective. They are not there. Now the remaining forces with us are F plus sin theta and F minus sin theta. Now similarly, components F plus sin theta and F minus sin theta are also equal in magnitude and opposite in direction, cancel each other, resulting into net force acting on the dipole to be 0. Thus net force acting on the dipole is 0, but here comes in but their line of action is different. Their line of action being different, the dipole experiences a torque. Now what is the expression for the torque, how we calculate? Let us see in the 6th step. But line of action of F plus sin theta and F minus sin theta is different, which results into a torque, that is turning effect, and the dipole rotates about its axis. Now what is torque? Torque is the turning effect of the forces. It is equal to either of the two forces into perpendicular distance between the forces. This is the mathematical definition of torque. Torque is the turning effect of the forces, and it is equal to either of the two forces into perpendicular distance between the forces. Here the two forces which are resulting into torque are F plus sin theta and F minus sin theta. Okay, and perpendicular distance between them is 2a. So how we write the expression for the torque? Tau is equal to F plus sin theta into 2a. So to take F plus sin theta into 2a or F minus sin theta into 2a, because F plus and F minus are equal in magnitude. Okay, so we put the value of F plus as QE. Now Q into 2a, we rearrange Q into 2a into E sin theta. Now Q into 2a is P. Q into 2a is P. So we write torque is equal to PE sin theta. We write the torque tau is equal to PE sin theta or P cross E. Okay, so final expression we get torque is equal to P cross E. So this is the expression when a dipole free to rotate about an axis passing through its midpoint perpendicular to dipole axis, when placed in uniform electric field, experiences a torque. Tau is equal to P cross E or mod P mod E sin theta. So this is the expression for the torque experienced by the dipole. Now we come to discussion part of it. Now when first point we say tau is perpendicular to P, also tau is perpendicular to E. So these are the two pairs of vectors which are perpendicular to each other in the expression of the torque. Now when theta is 0, then P is parallel to E and then torque is 0 minimum. So dipole is in stable equilibrium. Third point, when theta is 90 degree, dipole moment vector, that is P, is perpendicular to E, and then tau is equal to P into E, because torque will be equal to mod P mod E sin theta, and theta is 90 degree. So tau will be equal to P into mod E and is maximum. So dipole is in unstable equilibrium. Okay, so these are the discussion points about the electric dipole when placed in uniform electric field. Now assignment 1.4. Continued, question number 10. An electric dipole with dipole moment 4 into 10 raised to power minus 9 coulomb meter is aligned at 30 degree with the direction of uniform electric field of magnitude 5 into 10 raised to power 4 newtons per coulomb. Calculate magnitude of the torque acting on the dipole. and the answer would be 10 raised to power minus 4 Newton meter. So unit of torque is always mentioned as Newton meter and not as Joule. Okay. Now assignment 1.4 continued. Question number 11. An electric dipole with moment P is placed in uniform electric field of intensity E. Write the expression for the torque experienced by the dipole. Of course, the expression for the torque tau is equal to P cross E. Identify two pairs of perpendicular vectors in the expression. Means tau is perpendicular to P, tau is perpendicular to E, because the resultant of the cross product is perpendicular to the both vectors. C. Show diagrammatically the orientation of the dipole in the field for which torque is first maximum, then half of the maximum value, and third 0. So you have to draw the diagram showing P vector and E vector, okay, in all the three cases. Now this is all about the electric dipole. When placed in uniform electric field, it experiences a torque. Now what about its potential energy? That we'll take up in the next part of it. Thank you so much. God bless you.